In this question, you are asked to determine the correct order of ionic conductance at infinite dilution. So, ionic conductance at infinite dilution is a very important question because this deals with the fundamental theory of ionic atmosphere. So, what is ionic atmosphere theory? Whenever there is an positive central ion, there will be negatively charged ions around it. With electron neutrality principle, it will be having a zero net charge, meaning to say these negatives are delta negative or delta delta negative charges. So whenever the central ion is moving, it is not moving alone, it is moving along with the ions surrounding it. So that is the theory of ionic atmosphere. Along with the ions, there will be the water molecules also, if they are associated with that one. So that is the theory of ionic atmosphere. Now let us see the options. So we are given with the options of hydrogen ions, H plus, you have Li plus, you have Na plus, and you have K plus. So if you check the periodic table, you can see this comes in this particular first group, hydrogen. So hydrogen is not in that one. Lithium, sodium, and potassium are there. Now we know that the ionic size increases in this side. Ionic size. Why the ionic size increases? Because from moving down from one period to another, each time there will be a additional shell will be increased as per the electronic configuration. So ionic size increases here. And now once you see the ionic sizes, immediately you may feel that the larger size will be for potassium. No, the large size is not for the potassium. Large size, the ionic size is large for potassium, but to check that one we have to see the hydrated radius also. So moving into hydrated radius, you should know what you mean by the charge density. What is charge density? The density of charge associated with a ion. So if you take these ions Li plus, Na plus, and K plus, here Li plus, all the ions are having a charge of plus 1, right? All are having a charge of plus 1. Now you compare the sizes. The size is much higher for potassium, lower size for sodium, and lithium will be having a much smaller size. So if we check the charge density, the same plus 1 charge is deposited is on this smaller size one. Again, here also the total charge is plus 1 on a much higher sphere. Here again only plus 1 charge on a very large sphere. So if you check the charge density, the order will be like charge density's order will be Li plus greater than Na plus greater than potassium. So this is the charge density. So if the charge density is more number of water molecules will be associated with lithium. So if this is lithium, more number of water molecules will be associated with it, so that the hydrated radius also will be higher. So hydrated radius, will be having the same order as Li plus, Na plus greater than K plus. So that will be the order of that conductance. So now you can check for the option, but before moving to the option, let us see the position of the hydrogen also. H plus ions, generally it is explained as it is having a Grothuss mechanism. That mechanism is called as Grothuss mechanism, because the conduction of H plus ions is little bit different. It is not moving from one side to another. Actually, if you check this particular molecule, it is a water molecule. This is hydrogen, and this is an H plus. So it is existing as an H3O plus. So what is happening is that from this H3O plus, one H plus is going to be donated to next water molecule, and this water molecule will donate its H plus to here, and finally it will come to the last molecule. So it is like a chain transfer mechanism, and after the transfer it will be looking like this. Here there is no H plus, and H plus has been transferred to this particular molecule as here. So this is the transferred H plus molecule. So Grothuss mechanism is very fast, very fast. That is why H plus ions are having the maximum conductance. It is almost similar with OH minus ions also. So Grothuss mechanism explains the conductance of very high conductance of H plus ions and OH minus ions. Now let us come to the options. So if you check the options, we know for H plus ions it should be the maximum one, and then it should be for potassium, because it should be the inverse of the charge density or inverse of the hydrated radius. So it should be for potassium, Na plus and lithium. So your correct option should be 4, meaning to say lithium is having a higher hydrated radii because of its higher charge density, because of its smaller ionic size. So the right option is fourth one.